You know, when you look deep into the night sky, way past the stars you can name, and just stare into that silent black void, what are we actually looking at? And then you see something like this. Suspended in all that immense darkness, there's this faint, fiery streak. It's an image that has traveled millions of light years to reach us, a beautiful, kind of strange whisper from the deep cosmos. But what in the world is it? Is it just one object? Maybe a distant nebula? Some kind of massive star exploding? Well, the real answer is so much more dramatic than you're probably thinking. What you've been looking at are not one, but two galaxies, and they're locked in this spectacular cosmic dance. Astronomers have even given them a pretty charming nickname, the Mice. So here's the crucial thing to get. This isn't a static picture. We are literally witnesses to a colossal event that's been unfolding for millions of years. A full-on galactic collision. Two huge collections of stars, gas, and dust are in the middle of this slow, incredibly powerful process of merging into one. And just look at that amazing glowing tail. You might think that's from an explosion, right? But it's actually what's called a tidal tail, a super long stream of stars and gas that's being pulled right out of one galaxy by the insane gravitational force of the other. And yup, this is exactly how they got their name. That long, curving streamer of stars just looks so much like a mouse's tail. So astronomers gave this absolutely epic event a surprisingly down-to-earth nickname. Okay, but how in the world do we get such a clear and, frankly, artistic view of something so incredibly far away? Well, the process is just as fascinating as the image itself. It's all about turning raw data into cosmic art. See, we're not just looking at a photograph in the way you'd think of it. These images are actually built from raw scientific data files, and they're processed using this professional astronomy software. This stuff lets scientists tweak and adjust the view to reveal details that would be completely invisible to the naked eye. To really see what that means, we can look at a few different versions of this very same collision. Think of it like applying different filters, where each one is processed to tell a slightly different story. All right, check this out. On the left, we've got a view that's trying to show a more natural appearance, but on the right, whoa, by pushing the data to its absolute limits, astronomers can highlight these incredibly faint structures. That bright cyan color, that's bringing out all this wispy material that was pretty much invisible before. And here's another comparison. The image on the left gives us a super clear look at the star field all around them. Every little dot is a star in our own galaxy or some other distant one. But then the image on the right kind of filters out all that background noise, and it uses those greens and blues to focus our attention right on the hidden details of the galactic mashup itself. So you see, each adjustment has a purpose. By messing with the brightness, the contrast, the color, scientists can basically choose what they want to study. The faint outer edges, the busy star field, the natural look, or the very core of the collision. It's like having 4 different kinds of eyesight. Seeing these galaxies this way does more than just give us a pretty picture. It fundamentally changes how we think about the cosmos all around us. And this right here gets to the most profound takeaway from an image like this. It's a powerful, powerful reminder that the universe isn't just a static, unchanging backdrop. No, it is a dynamic, almost living system that is constantly in motion. The Mice Galaxies are perfect proof. We are watching evolution on a galactic scale. It's a process so slow and so vast, it's almost impossible for our brains to comprehend. What we see as a single moment is just one tiny part of a story that lasts for eons. It really makes you wonder, doesn't it? If this incredible collision is happening out there, what other cosmic dances, what other beautiful slow-motion dramas are unfolding right now, just beyond the reach of our telescopes?